Applications of ultrasound. There are many applications of ultrasound, and they are used in industry, in hospitals, and to study the sea life, and in many ways it is used. So to study the human body and its organs, etc. So let us see one by one. The first application is in industry. How is it used in industry? See, one feature of ultrasound is it has high frequency. Because the frequency is very high, wavelength is short. So because of which what happens, they can penetrate into the matter to a large extent. So most of the waves will go into the matter. Since they can penetrate into it in a large extent, we can do the study of detecting the flaws. There are two properties which will make us detect the flaws in the metallic blocks. Or see, in a construction of any building, we use the metallic blocks, and there may be a particular crack that is developed in the middle somewhere, and if we do not detect it, then it may be a danger to the building itself. So in order to detect that crack, this ultrasound waves are used because of its two properties. One is they can high penetration, rather we will say, penetration is high because of its short wavelength, and they travel in straight lines. See, they travel in straight lines without bending at the corner. So this is an important property which is used in detecting the flaws. So in industry and hospitals, they use it to detect the flaws. For example, flaws or cracks. So example, let us take it, detecting flaws in metal blocks. They detect the flaws and they do not damage the blocks. So that is the beauty of ultrasound, without damaging the block. So the internal cracks reflects the ultrasound waves that fall on them. That is the principle. See, let us take a metallic block, and then we are sending ultrasonic waves. They are being detected by detectors. Let us say these are detectors. So these are detectors, and this is a metallic block, and these are ultrasound waves. They travel in a straight line and detectors detect them. Now let us say it has a crack. There is a crack here. Now the ultrasonic waves are going straight. When there is a crack, it doesn't move beyond this crack. What happens in this case? These two get detected by this detector, but this detector does not detect anything. So we know that because of the crack, this ultrasonic sound is not detected by this detector. So there is a crack in this particular place. That is how the cracks are detected, because the internal cracks, what they do, they just reflect the sound waves back. So these are the reflected waves. So from the cracks, the waves get reflected back. So basically what we say, internal cracks or flaws reflect the sound waves. See, if we use ordinary sound waves, they also reflect. Then why we use only ultrasound, not ordinary sound? Because ordinary sound waves have a property to bend around the corners. So if it is ordinary sound wave, then it will bend around the corners and somehow reach the detector. then we will not have a clear understanding of the crack, because detector detects. That is the reason why we use ultrasound waves for detecting the flaws. So we need to make a note that ordinary sound waves bend around the corner and reach the detector. Since there is somehow, we don't use ordinary sound waves. It doesn't give us a clear picture of the crack. That is the reason why ultrasound is used. This is the first application. Let us see the second application. Ultrasound waves are used to clean the places which are hard to clean otherwise. Like for example, spiral tubes or odd-shaped machines or electronic components. So to clean them, it's very difficult. Electronic components will have many pins and very small. So it's very difficult to clean inside of those electronic chips and all that. So in order to clean them, these ultrasound waves are used. How it is being used? What is the principle which helps us to use this? What happens is, these ultrasound waves, when they hit these objects and the dust particles or grease, anything which is left on those objects, they become loose. They vibrate and become loose, and they get detached from the objects and get into the solution in which the objects are placed. So that is the way it is done. So for example, if we take, let's say a solution is there in a beaker and we put an electronic component which is having several pins on either side, and now we make the ultrasound go through it. These are the ultrasound waves. So what happens basically is, when they go in, when they hit the object, so they will make the grease and the dust and whatever the dirt which is there, which is to be cleaned, they vibrate because of these waves. When they vibrate, they become loose and they get detached from the object, that is the electronic component in this example, and they fall into the solution. So that is how the components can be cleaned thoroughly. So the second application is to clean. So ultrasound is used to clean hard to reach parts of objects like spiral tubes, odd-shaped machines, and electronic components. Let's see the next application, which is basically used in the medical labs or in hospitals. So this is used for investigating the internal organs of the human body, as liver, heart, gallbladder, and the organs like that. How it can be done? Because the ultrasound waves can penetrate the human body. Since they can penetrate the human body, and the reflections from that penetrations will be studied, and those reflections can be used to form, using the computers, we will recreate the organs and find out what is the problem with it. So the technique of obtaining pictures of internal organs of the body by using this echoes of ultrasound is called ultrasonography. So it is used basically to investigate the internal organs of human body by using the techniques like ultrasonography. Ultrasonography is the technique used. What does this technique mean? This technique is nothing but obtaining pictures of internal organs of the body by using echoes of ultrasound pulses. So by using echoes of ultrasound pulses, obtaining pictures. Pictures of what? The internal organs of human body. This is called ultrasonography. This is used even to diagnose the heart diseases. How it is done? using electrocardiography. So electrocardiography uses the ultrasound waves. They penetrate through the heart, and the reflections from the walls will give the study of the heart and anything is the problem with the heart. So that is nothing but identifying the problem, and then disease can be diagnosed. Electrocardiography, same by using the echoes of ultrasound, but what we do is it investigates the action of heart. So ultrasonography and electrocardiography, both of them use the ultrasound waves for identifying the problems. Now let's go to the next application, which is this is used to monitor the development of fetus. See, we know that when somebody is pregnant and the baby inside is called fetus, and this fetus will be scanned once in a while in order to see that the growth in the baby is appropriate. So for that, ultrasound scans are used. So ultrasound scans are used to monitor the development of the fetus inside the mother's womb. How does it happen? Again the same thing. Ultrasound waves are sent into the mother's body, womb, and then the reflections will happen by the baby, and they can form the picture of the baby on the computer and find out any problem is there or everything is fine. And it is also used to break the stones in the kidney, rather kidney stones. To break kidney stones into fine granules, ultrasounds are used. How it happens? Again, ultrasound waves are sent into the kidney, and then it will identify the stones. It will go and hit the stones. When it hit the stones, what happens is, with the high energy that is penetrated through them, they vibrate and they break into small particles or fine granules, and they just get mixed up and they will be flushed out. And the other example is sonar. So let us talk about sonar in detail, but it is used to measure the depth of the sea. So to measure the depth of the sea and to locate underwater objects. So what happens basically in the sonar? Let's say there is a seabed and there is a ship, and this is the seabed, and this is ultrasonic pulse. Ultrasonic pulse is ultrasound wave, and this is reflected ultrasonic pulse. Or echo, and this is transmitter. It is transmitting the ultrasonic pulse onto the seabed, and this is the receiver which is receiving it back. Now what's happening over here? In this, the transmitter is sending a burst of ultrasonic pulses from a ship to the downsea water. So what happens? The receiver picks up the echo. Transmitter sends the pulses, receiver picks up the echo. So what is the time taken for the echo to reach the ship is measured by the sonar. Sonar is an apparatus which measures the time taken for the echo to come back. After the ultrasonic pulse is transmitted, for this echo to come back to the ship, that time taken is measured by the sonar. So once you know this time, half of this time gives us the time taken for the ship to the object. Once you know the time taken for the sound to travel from ship to the object, knowing the velocity or speed of sound in water, we can find the distance. So from this, we will be able to find how far is the object from the ship. So sonar is a short form which is nothing but sound navigation and ranging. So it is navigating the ship based on the sound waves and the echoes, and it will find the range. How far is it from the ship? So that computation is done by the sonar. So what does the sonar do? So sonar measures the time taken for the echo to reach the ship. Let us say this time taken is t. Then t by 2 gives us the time from ship to the object. Once we know the time taken from ship to object, we know v as speed of sound in water, which is also a known factor, known data. Having known the v and t by 2, we can find the distance from ship to object. This will be v into t by 2. This gives you the distance. So this is what the sonar does. And the transmitter and receiver, generally in the sonar, what it does is they work on 50 kilohertz signal. They send 50 kilohertz signal, and receiver, when receives the echo back, it will convert it into electrical. So the receiver basically converts echo into electrical signal. This is the working of sonar. Remember that the speed of the sound in water, whether it is ultrasonic sound or ordinary sound, it is the same, 1500 meter per second. That is what we have seen it earlier. And the other application which we see mostly in animals is things like bats. What they do is they use a method called echolocation. See, bats can do two things. They use this echolocation method to locate the objects by hearing the echoes. Let us say there are some obstacles. So it locates the obstacles. How do they locate obstacles? Their ultrasonic squeaks. The ultrasonic squeaks by bats will hit the obstacles and then reflect back. So those echoes will be heard by them, and then they know that there is an obstacle and they will change their directions. This is called echolocation. They also use this to locate their prey, that is insects, for example. So what they do again, their squeaks will hit the prey and they will hear the echo and they will judge the range, the distance at which the prey is, and then they will go and kill them. So electrolocation is used to locate the obstacles in night, because night is the time they can't see, and also to locate their prey like insects, bats, and there are several animals like that. It's not just the bat. There is porpoises and dolphins, and many of these things will use the echolocation in order to locate objects in obstacles in night and also identify the distance at which their prey are. So these are many applications of ultrasound.